Yeah, just a moment. Yeah, okay. Mm, I'm requesting others also to share your, uh, like knowledge so that we can do the KTs, knowledge transfers. Okay. So I'm just explaining you what I learned and I mean what I understood about the data science. Okay. So first of all, I mean what I have done, I will explain. So first I learned a little bit Excel. Excel, this is mandatory. Okay. So Excel means you should know basic understanding of Excel. Okay. Maybe 10 hours is enough. Okay. Then later you should know the Excel uh, project, at least Excel projects, like 4 or 5 projects. Okay. So this already I finished. So I learned Excel for 10 hours and I prepared notes also. Then I worked on some 4 or 5 projects on Excel. Okay. Later, yeah, this is Excel. Later, Tableau. Tableau is data visualization purpose. So it is mandatory. Okay. So Tableau also, I think, just 10 hours of practice using this Tableau is enough. Later, after this Tableau, then you should start learning the R program. R programming. So I'm talking here not the statistical part, just R programming concepts. So how to install the R, what is the R and the difference between the R Studio. Then, I mean the basic language you should know. So that is R programming language. Next, Python. So Python language. Okay. So Python language, the concepts, what is NumPy, what is pandas. Okay. So I mean, those are the things related to the Python. It is not. I mean, I'm not talking about the machine learning or deep learning or any neural networks. Just understanding the Python language. Okay. So that is nothing but the core Python. So core Python. So these are mandatory, and some people are saying that it's better to learn uh, this one also. BI. There is one Microsoft BI is there. Okay, let me show you. I installed in my system. Power BI. So that's a Power BI. Power BI. Okay. So some people are saying that it's better to learn the Power BI also. The reason is uh, in the Power BI as well as in the Tableau. Okay. So one feature is available. The feature is storytelling. So storytelling feature. I don't know how many of you know the storytelling feature. Okay. So this is the feature is available in Power BI and Tableau. Okay. So you should learn this one also. Later coming to the databases. Databases. So SQL, it is mandatory. The basics, basics are enough. Like it is nothing but a querying language. Okay. So if you know what is a DBMS, okay, then what is a RDBMS, and like the basic queries, right? So queries. So this is mandatory. And later, anyway, I think Sarah also explained this MongoDB, right? So MongoDB, MongoDB, as well as he explained MySQL also, MySQL. Okay, so this is one. But actually, no need to do any type of programming here. I mean, no need to learn all these things in detail. If you know the connectivities, that is enough. Because And one more thing, big data also. Understanding the big data concepts. Okay, then HDFS. Okay, yeah, this one, big data concepts and HDFS. Like in the HDFS, we have a lot of things, right? Hive, uh, pig, zookeeper, uh, zookeeper. Okay, so etc. So why we need to understand the big data means we are doing the big data analytics, right? Big data analytics. So big data analytics means the data will be given to us. I mean, huge data will be given to us. So how to connect? See, databases are available. So in those databases, there is a huge data. I mean, present in the databases. So within the databases, it is not possible for us to analyze the data. So that's the reason we are searching for the analytical tools. So we have a lot of analytical tools in the market, like SAS is there, R is there, Python is there, and I mean, etc. Multiple analytical tools are there in the market. But uh, the Python, it handles huge data. R also having some limitation. SAS also having some limitation, but there are some tools related to SAS like SAS VIA. Okay, SAS VIA is there. So using the SAS VIA, we can perform the machine learning and deep learning algorithms and everything we can do using this SAS VIA. So data science means the data analytics can be done by using mostly these three tools, which are famous. The first one is Python, the second goes to the R, and the third is SAS. But the SAS is very costly software, so that's the reason most of the companies are not using the SAS software. So they are looking for the freewares only, or some enterprise editions with limited money. So R and Python. Okay. So you should know the how to perform the analytics using the R and Python. So these two are mandatory. So understanding the databases, this one is important, SQL. Then MongoDB, the connectivity is important. So what do you mean by connectivity means? See, for example, I have Python, okay, or I have some, I mean, I'm using Python as a analytical tool, okay. So somebody gave us the data in the form of Hadoop, okay, Hadoop or big data Hadoop. So you should know how to connect your Python tool to the Hadoop because you are performing the analysis on the data. The data is given in the form of the Hadoop. So you should know the concepts of Hadoop. So what is Hadoop? What is HDFS? What is the Hadoop environment? What is the Hive, Pig? We have a lot of things in this Hadoop, right? So you should understand this concept. This is very important. It means the connectivity, how to connect our analytical tool with the Hadoop, that is important. And how to connect our R, Python to the MongoDB also very important. And even MySQL also. Connectivity is very important because the connectivity means to perform analysis, we need the data initially. So to get the data, we need the connectivity. So how to connect to different databases is very important. I think, I mean, that Prasad sir, right? I mean, DS Kumar, he explained a lot of times like how to do the connectivities like R to MySQL, MongoDB to R, Python to MongoDB. So he explained, right? So understanding the databases, this SQL, it's a mandatory. The remaining databases we need not to learn. If you know the connectivity, that is enough. Okay. Then coming to the analytics. So analytics means first thing is we should know some basic algebra, right? This I think you know. So we are not learning the algebra separately. While learning algebra and calculus, I mean, while learning some, the statistical part, okay. So the basic algebra and calculus also needed. So without knowing this basic algebra and calculus, okay, it is little bit difficult to understand the probabilities and machine learning and deep learning algorithms also. So that is the reason basic algebra and calculus is needed in the mathematics part, maths part.
Sorry, voice of me.
Sorry. Yeah, you can hear me, right? Manas,
Yes, we can hear you.
it's clear,
Yes,
right? Oh,
yes.
okay, okay, fine. Uh, yeah. Okay, so this is the math part we should know. Then coming to the statistics. Statistics. So this is the, I mean, usually the people feel that this is the toughest part, right? Because these things easily we can understand, like their databases we will understand, okay, because most of us are from the programming background, so we can easily understand the databases, and we can easily understand these language also, Python language, R language, and in Tableau and Power BI there is no any programming. Excel easily you can understand, right? And we can prepare a notes also in this. But coming to the statistics is the toughest part, because the statistics is a separate science, right? In degree level we have the statistics, in PG level we have statistics, and even I mean there is a I mean PhD also there in statistics. So statistics is like a different thing. But here no need to bother about the statistics. The basic statistics is enough. Okay, so basic statistics means uh, in the biostatistics. Biostatistics means like in the healthcare industry and in the life sciences also we use some statistics, that's called the biostatistics. So biostatistics and business statistics, and I mean we have statistics in different industries also, like market research also, market research. Okay, but uh, we should not worry about the statistics whatever we use in different areas, because once you learn the basic statistics, the same basic statistics we can apply in the biostatistics also, business statistics also, market research also, in other areas also. There is no separate statistics related to the bio or business or market. Okay, because here we are not learning the statistics deep. The basic understanding of the statistics is important, because to understand the machine learning algorithms and deep learning algorithms, we need these basic statistics. Okay, so I mean, actually, I have done 1 year course on statistics and data management. Not now, almost like 15, 14, 15 years back, I think. So I have a little bit of understanding. So that's the reason I want to share my, the statistical knowledge, whatever I have, because I am from the life sciences background. I'm not well versed with the statistics. So it is just, just I want to share my knowledge, and also I want to get something from you. Okay, because I'm not from programming background, so might be you're from programming background, so I can learn some programming skills also from you, and also how you are, I mean, how you started learning this data science. I mean, we can mutually exchange, right? So that's the reason I thought to, you know, start this session. Okay. So thank you for your encouragement and cooperation. Then, yeah, so these are the things we should know. And yeah, in the analytics, basic math, the statistics, when that is a basic statistics. Later, algorithms like machine learning, then deep learning, then we have the neural networks also, neural networks, then text mining, so data mining concepts. Okay, so yeah, these things we should learn. So these things we should learn how to do with the R and how to do with the Python also. Okay, so the same, first of all, we'll take one example. The same example we'll do using the R as well as with the Python also. Okay, and even Excel also, because the most of the things we'll do by Excel only. Okay, so if you are doing something, for example, let's take the linear regression. We'll take some data, we'll perform the linear regression using the Excel, and we'll use the same data and we'll perform the same type of linear regression using the R and Python, and we'll see the differences, like I mean, how the Excel is giving the results and how the R and Python are giving the results. And we can perform the same linear regression in a visualization mode using Tableau and Power BI also. Okay, I mean, all these tools will be same, right? I mean, tool is different, but the concept is same. Okay, the input, data input is same, but uh, I mean, the process will be different. The feeding into the uh, what we say, the feeding into the tool, okay, and writing the code will be different, but the result will be same. And one more thing here, understanding the result is very important. So that's called the interpretation. Interpretation is very important. Interpretation we also call the drawing the inferences on the data. I mean, we'll get the output, But what is the use of that output? First of all, you should draw some inferences on the output. We got some p-value as 0.5 or 0.4. So what that p-value indicates, okay? So those things we'll be learning in the statistics, okay? So we have like this one. One is the programming, okay? Then the second one is databases. Then database connectivities. Later, uh, tools, tools. Then stats and algebra. So if you can learn in a sequence, it will be easy. Okay. So actually, what I have done, I finished this part actually. The Excel I finished. Excel projects also finished. Tableau and Power BI I finished little bit, not completely. And R programming language and Python also I finished. I mean, just the basics only, not the statistical part and not the machine learning and deep learning concepts. I just learned the R and Python. Just just like other programmers do. Most of the Python programmers, they are not perfect in the machine learning and deep learning using Python. They know the core Python. That's it. Okay. So they can't perform any type of them algorithms like machine learning and deep learning algorithms using Python. But they are the Python programmers, right? So I mean that part I learned core Python. Okay. Okay. Let us discuss this basic statistical part. Uh, we have, I mean, so many tools. Okay. So I gathered some material also. Yeah. So this is enough for us. There is a huge statistics. I mean, statistics are available, but we don't need all those statistics. This is enough. First, anyway, we'll discuss about the introduction, like visualization, what's a box plot, box plot, and bar chart. Okay. Then what is a histogram? So those things we will discuss later. Data description. So this is very important. Once we have data, then we have to describe the data. See, without describing the data, without understanding the data structure, it is very difficult for us to perform the analysis. For first thing is understanding the data is very, very important. What type of data we have, how much data we have, whether the data is having errors or not, whether it is having any missing values or outliers. So we have to explore the data first of all. Okay, that exploring also it will be in the exploratory data analysis. We have a separate concept called the EDA, exploratory data analysis. So there we will be talking about the, I mean, the exploration of the data. So first data description is important. Then later after data description, we'll be moving to the probability. Probability is very, very important. Without understanding the probability, we can't understand the normal distributions, we can't understand the Poisson distribution, and it's very difficult to perform any type of the analysis. The probability is very, very, very important. So what is probability? Okay, I think you know what is the probability. If you toss a coin, I mean, it will give head and tail, right? So that's the basic starting of the probability. But in the probability, we have a lot of things to discuss. So the probability itself will take like 2 to 3 hours to understand the probability. Then probability distributions are there. All the distributions will come under the probability distributions. Then once you are good with the probability distribution, then we can start with the sample distributions and estimating. Sampling is very important. What is the population and what is the sample? And we have a lot of sampling techniques are there. So we'll be discussing those sampling techniques also. Okay, like stratified clustering. We have a lot of sampling techniques are there, random sampling techniques are there. So we'll be discussing the sampling techniques, how to select the good sampling. I think our sir also he explained about the sampling techniques, right? So that is sampling techniques and estimating also will be done. Then later, this is very important concept. What is hypothesis testing? This one also sir explained, but I will explain by taking my own data set. Okay. What is hypothesis? What is null hypothesis? What is the alternate hypothesis? What is the, I mean, like, I mean, left sided hypothesis, right side hypothesis, and uh, after getting the results, then how to accept your hypothesis or how to reject your hypothesis, how to reject null hypothesis. Okay, and where you should apply this hypothetical, I mean, concepts in our data. Okay, then data is divided into two types, as you know, parametric and non-parametric data. So if it is a parametric, what type of hypothetical procedures we have to use? If it is a non-parametric, then what type of procedures we should use? Then if it's a categorical, then some procedures are limited to the categorical data, and some are limited to the continuous data. So all these, like what is discrete, what is the ratio, what is interval data, what is continuous data, what is dependent data, what is the predictor variable, what is the analysis variable, what is semi-analysis variable. All these things will come under the data descriptors on. So in the data description part, I will explain the all the concepts. Then chi-square is for the qualitative data. Okay, and yeah, I mean, in this we have a lot of hypothetical testings are there, like t-test, ANOVA, GLM, paid t-test, independent t-test. So we have a lot of things, that z square, f square. Okay, so those things also we'll be discussing. In the later, linear correlation and regression analysis. So in the regression analysis, again we have a lot of regression analysis. Okay. The linear correlation is simple only, but coming to the regression analysis, we have a lot of regression analysis, which are very basic for the machine learning concepts. I mean, once you know this, understanding the machine learning algorithms will be very easy. Then coming to the time series, these things will come under the statistics. Okay. So I mean, we should not say all these are the machine learning algorithms are deep learning. This is just a statistical part. If you know the statistical part, then we can start the other algorithms. You can understand very easily. Okay. So I prepared some charts also. So I told you, right. So this is the PowerPoint presentation. I think at the time of learning, I mean, when I was doing the course, so there I got these slides. I think they are like 2013 Oxford University Press slides. Okay. Yeah. So visualizing and presenting the data. You know this. Using the Power BI, you can use the Tableau, or you can use some. I mean, so many tools are there. In SAS, there is a VA tool, Visual Analytical tool is there, and so many tools are there for the data visualization purpose. Even we can use the Excel also for the data visualization purpose. Right. Then I mean, this already we know, because already I think first or second, third sessions he explained the data visualization, right? So using the Tableau and R also. Then yeah, then coming to the statistics. So we have two things. One is the descriptive statistics. The second is the inferential statistics. But people will classify the statistics as per their convenience. Like some people they say simple statistics, descriptive statistics, inferential statistics, associative statistics, prescriptive statistics, predictive statistics, like that. So they will classify based on their convenience. Okay. Even we will talk them. I mean those classifications also. But here this slide is showing that we have two types of statistics. One is the descriptive one, the second is the inferential statistic. So what is a descriptive statistic? Descriptive means it is like exploratory data analysis. If somebody gives you the data, then first of all you have to describe the data. What the data is. Okay, how is the data? Whether it is normally distributed. Because before applying a procedure on that, we should have a good understanding of the data. So we have to explore the data. So that exploration comes under the descriptive statistics only. Means uh, these statistics will help us to describe the data structure. Okay, so like central tendency, dispersion, skewness, kurtosis. So all these will come from the descriptive statistics. Then coming to the inferential means where we can draw the inferences on the data. So we have two samples. Let us assume we have two samples. So you want to find out the difference, I mean the mean difference between these two samples. So for example, uh, I mean, let us assume a patient is having blood pressure. Okay, let's take a systolic blood pressure. I mean, so we have given a medicine to them. Okay, uh, before giving the medicine, when we collected the systolic blood pressure and we made a one variable, okay, with all the values before taking the medicine. Then after giving the tablet, again we measured the systolic blood pressure, and now we got the two variables. One is before the tablet, the second one is after the tablet. Then you want to find out the difference. Means, uh, is there any tablet effect before and after? I mean, there is any difference in these two variables. So if you want to find the mean difference between these two, then what type of test to be conducted? Whether to conduct the t-test or whether to conduct the ANOVA, what type of test we have to conduct on this one. Okay. So that comes under inferential statistics. Means once you apply the statistical process on the data, you will get some result. So based on the result, you have to draw some inferences on the data. So what is that inferences you have drawn? So based on that, uh, you can reject your hypothesis, or you can reject your null hypothesis. So that comes in the inference statistics. Inference statistics, we have only limited, like up to ANOVA we can do. Okay. Then later coming to the machine learning and deep learning, again there also will draw some inferences, but mostly the predictive things we will be doing. The predictive analytics there we are doing. Okay. Usually we won't be drawing any inferences in that machine learning and deep learning. Anyway, we'll draw inferences, but it's not like a hypothesis. Okay. Then yeah, so this is very important one. So presenting the data. So we have two types of data, right? One is the categorical and numerical. So what is the categorical and numerical? Okay, let me write it here. Okay, so categorical, numeric data. So what do you mean by categorical data? Yeah, you can see this slide, right? Presenting the data, we have two types of data: categorical, numeric data. So categorical means we have so many names. We call it the qualitative data also. Qualitative data, or we also call it the classification data. Okay, then yeah, we have so many names are there. See, for example, sex, male and female. Okay, so we are categorizing the sex into two categories, right? Male and female. That's it. Okay, so there is no any number in this, right? In the values, there won't be any number. Though the number is there, it comes in the category. For example, we are calling one as a male and two as a female. The numbers are there, but this is a categorical data. I mean, where we can make the classification. It's a categorical, or else we can simply call it as a text data. Text data. Text data is the categorical data. Okay. Then what is the numeric data here? Numeric data we also call it the quantitative data. Quantitative data. Quantitative means it contains the numeric. We can consider anything as a categorical means we can consider anything as categorical. Like 0 to 9 also we can consider categorical. A to Z also we can consider as a categorical. Even symbols also we can consider as a categorical. Categorical means everything will come at the categorical one. Okay. Then what is the quantitative here? Quantitative means only the numbers. Only the numbers means 0 to 9. That's it. The only quantitative is the numbers. If the data is quantitative, then we'll be applying only some statistical procedures. If the data is categorical or qualitative, then we'll be applying the statistical procedures related to the qualitative only. So it's not possible to apply the same procedure on both the qualitative data as well as the quantitative data. So we should learn like what procedures are applicable to the qualitative data and what are the procedures applicable to the quantitative data. So let us see here in this presenting the data, categorical and numerical. Okay, let us see the categorical. We can present the categorical data in the form of tables. Tables means again we have different types of tables like one dimension table, two dimension table, three dimension table. I think you know this one, or else I will explain. There are three types of tables: one dimension, two dimension, three dimension tables are there. Then graphing data. Graphing data also the categorical data we can visualize. See here we are talking about only how to present your data. That's it. We are not talking about the nominal, ordinal. Okay, that is a different data types that comes under the data description part. But how to present our data in the form of tables, in the form of graphs, in the form of frequency distribution. So graph means like bar chart, pie chart, and in the free, yeah, this is the categorical. Then coming to the numerical one, numerical means frequency distribution, histogram, polygons. Then cumulative distribution. So og1 cumulative frequency graphs. If it's a bivariate, then we'll be presenting the data in the form of scatter plots and time series plots. Okay. I will show you all these things. Yeah. Then coming to the different types of variables. So this part is very important. I think everyone knows this. What is a variable? Variable means it is a like column, right? It's a column which contains the variates. Variates means one single item, okay, is called, or one observation is called the variate. So all the variables together will form one variable. Okay, or a line, like a column, a measurable column, right? So the variables may be qualitative or quantitative. Just now we discussed qualitative and quantitative. Qualitative means it is a categorical one. Okay. Then quantitative means it is a numerical one. Then in the quantitative, yeah, coming to this qualitative, uh, yeah, I hope you understand this. What is the categorical and numerical? Then later the other part is nominal. So what do you mean by nominal? Nominal is a part of quantitative. So coming to the quantitative, we have two types. The quantitative one is nominal. The second one is ordinal. So what do you mean by nominal? Nominal is, for example, uh, okay, let, let me explain this ordinal first. Uh, what is the disease status? What is the disease status? Means the disease started with mild symptoms. Later, it leads to moderate symptoms. Then finally, it became severe. Okay. So we have a variable called the disease status. Disease status. Okay. So in this disease status, I am using only three values: mild, moderate, severe. Okay. So this is an ordinal type of variable. Okay. So here, how is the mild, moderate, severe? They are following an order, right? Mild, first mild symptom, then later moderate, then later severe. Okay. So they are following an order. This variable contains values, but these values are following an order. So this type of variable is called the ordinal type of variable. Nominal means it won't follow any order. See, for example, the color of the people, okay, or race. What is the race? Asian or white, Hispanic, okay, black people. Is there any order? You can write either Asian first or white first or Hispanic first, anything. There is no order. So this type of data is called the nominal type of the data. You take the sex or gender, you take the gender. So male, female. So which one you prefer to write first? There is no any order, right? So this type of data is called the nominal type of the data. So this nominal and ordinal type of data comes under the categorical type of the data, okay, not the quantitative data. Okay. So in the categorical we have two types: nominal, ordinal. Which follows an order is called ordinal. Which won't follow any order is called a nominal. Okay. Then coming to the numeric data. So in the numeric data we have like interval and ratio. So what do you mean by interval and ratio? So this is also important and it's not confusing also. So what do you mean by interval and what is the ratio? Interval means, see, okay, first let us discuss the ratio. Ratio data are continuous data, okay, where, yeah, and before understanding this interval ratio, uh, better you understand in the numeric one there are two types. One is discrete, then the second one is continuous. Continuous. So what do you mean by discrete data and continuous? So discrete means, see, for example, how many children you have? Two children. Okay, this is my answer. How many cigars you smoke per day? Like 5 cigars. Okay, so there is no any decimal value here. Okay, we cannot say like 2.2 children I have and 5.1 cigar I smoke. So it contains no any decimal values, right? No decimal values. So this type of data is called a discrete variable. Discrete variable. Okay, there is no meaning if you write 2.2 children, right? So the discrete means it's not possible to make any decimal values. That type of data is called the quantitative discrete data or numerical discrete data. And what is this continuous one? Continuous means it contains the decimal values. What is your weight? 50.5 kgs. Okay, like this. So what's your height? So my height is like 176.5 centimeters, like that. So it contains the decimal values. In the numeric, we have the discrete and continuous. Okay. Then in the same numeric, we have ratio and interval. So what do you mean by ratio? Ratio means, see, this term is very important one. Coming to the ratio, the ratios are having a natural zero. Okay, ratio data are continuous data where both differences and ratios are interpretable and have a natural zero. Okay, see, for example, what is the, I mean, what is a milk and water ratio? What is a milk and water ratio? Okay, so for example, in 4 liters of milk, okay, we added 1 liter of water. So what is the ratio here?